In this video, we discuss approximating the sample mean of a data set given its frequency distribution rather than the original data set. So in order to do this, we're going to do the following. We're going to follow this procedure. I'm going to explain more of why this procedure produces a number that's an approximation of the mean in just a moment. But if we have a frequency distribution, that means we have a number of classes. The first thing that we do is we find the class midpoint, and we denote that by x. Then we take those x values, those class midpoints, and we multiply by the corresponding frequency, and then we add them all together. So you've got your midpoints times frequencies, and then you add them. Then you want to add up all the frequencies. Now that's the same as your sample size, n, and then you divide. So the sample mean, which is represented by x bar, that's the sum of all of the x values in your data set, or all of the values in your data set divided by the total number of values. That's approximately equal to this formula on the right-hand side here. Since we don't actually know the data values, we're approximating them with the class midpoints for each class. And then we're taking each of those and we're multiplying by the frequency. And we'll see what that means and what that looks like in an example in just a moment. And then adding up the frequencies is the same as finding the sample size. We'll talk more about that in our example. Okay, so let's apply this to a data set or a particular frequency distribution. These are the same McDonald's lunch service times that we've seen in other videos and other lessons. We're asked to use the frequency distribution in the first two columns to approximate the mean. So we've got 11 McDonald's lunch service times that all lied between 75 and 124 seconds. Between 125 and 174 seconds, we had 24 values. Now remember what this means. These frequencies tell you, if you were looking at the original list of data, there were actually 11 values that were between 75 and 124 seconds. So there were 11 people that were waited on in 75 to 124 seconds when they went to McDonald's. 24 customers waited between 125 and 174 seconds to get their food. 10 customers waited between 175 seconds and 224 seconds to get their food, and so on. So each of these frequencies represents an actual data value, and each of those data values represents a customer. So if we're looking at the sum of those values, that's the same as saying we've got 11 values here, or 11 customers here, 24 customers here, 10 customers here, 3 customers here, and 2 customers here. How many total customers do I have? Well, I just add them all together. So that's giving me the same number as the sample size n. It's just representing it in a different form. So we're going to compute the sum of those frequencies for our denominator and our approximation of the sample mean. Now, in the numerator, what we would normally have when we calculate the sample mean is the sum of all of the data values. But when we have a frequency distribution, we don't actually have all the data values. I don't know what the particular values were that were between 75 and 124 seconds. But I know that there were 11 of them that were between 75 and 124 seconds. So what we do instead is we say, I don't know what those 11 values were, but maybe I could replace them, or maybe I will replace them with the class midpoint and say, those 11 values are probably, on average, equal to the class midpoint. They are about the average of 75 and 124 seconds, or the arithmetic mean of 75 and 124 seconds. So we can calculate that class midpoint and use that as a stand-in replacement for the actual values themselves. And we can say that makes sense because some of them were likely to be closer to 124 seconds, and then some of them were probably closer to 75 seconds. Even though we don't know exactly how they were distributed, we can guess that most of them, if we, it all balances out if we use the class midpoint basically as an approximation. So we'll calculate the class midpoint for each of these classes, and then we will multiply by the corresponding frequency. And that's basically giving us an approximation of the sum of the data values in that class. So I have the sum of the data values in this class by multiplying X and F together, and an approximation of the sum of the data values in this class by multiplying the class midpoint and F together, and so on. And then we add all of those up, and that's an approximation of the sum of the data values. So I take that approximation of the sum of the data values and I divide by the total number of data values, and that's giving me an approximation of the mean. So if I want to actually do this, I need to do some calculations. I need to find my class midpoints, and I need to do a little bit of multiplication. We can use Excel for this, but we can also use pencil and paper. So I think we'll just use pencil and paper this time, so that we have a good sense of what's going on. And then once we understand exactly how it's being done, we can use Excel to do the calculations for us later. I'm getting my document camera set up over here. Okay. I'm going to stop sharing this and share my document camera with you instead. Hi. Let's see. Okay, so we've got our times, those lunch service times, and then we've got the corresponding frequency right there. If I want the class midpoint, remember how we do that? It's just the mean of the lower class limit and the upper class limit. So you add the 75 and the 124 together, and you divide by 2. And we get that value. I want a decimal. So I get 99.5 as my first class midpoint. Now to get to the next class midpoint, I can just add the class width, because going from class midpoint to class midpoint should be the same as going from lower class limit to lower class limit. So the class width is the difference between this 125 and 75, which is just 50. So if we add 50 to this, we'll get the next class midpoint. And if we add 50 to that, we'll get the next class midpoint. And if we add 50 to that, we'll get the next class midpoint. And then if we add 50 to that, we'll get the last class midpoint. Now, if you're not sure, you can always just add these together and divide by 2. We should get exactly the same answer. So let's try it for this 174 to 224 class. So you have 175 plus 224 divided by 2. And do I get 199.5? I sure do. Okay, so this is the approximate wait time in seconds, or lunch service time in seconds at McDonald's that is associated with that class. So there were actually 11 customers or 11 people in our data set that waited between 75 and 124 seconds. Since we don't know actually how long they waited, we're going to say, suppose all 11 of them were waiting for 99.5 seconds. We're just approximating. We're saying some of those were probably higher and some of those were probably lower. So it probably all balances out to be something like this. That's why this is an approximation and not an exact value. Now, if I want to add up the wait times, or the lunch service times, excuse me, all of those that are in this class, I would just typically just take them all and add them together. I would be adding 11 numbers together, and that would give me my value. It would be the sum of the lunch service times for those service times in this class. But since I don't actually have those, I'm just going to take this 99.5 as a stand-in, and I'm basically going to add that to itself 11 times. I'm going to assume that the first time was about 99.5 seconds, and the second person was waiting for about 99.5 seconds. And since there were 11 of them, the sum of those 11 is just going to be 99.5 added to itself 11 times, and that's the same as just multiplying by 99.5 by 11. So you take the frequency, that's the number of people that were in this class, and you multiply by the class midpoint to get an approximation of the sum of the lunch service times that those folks had to wait. And it's not exact, but our hope is that it's close. This is 1,094.5. And we'll do the same thing in the next class. These 24 people waited about 149.5 seconds, or were served in about 149.5 seconds. So that's 3588. And these are all seconds as totals. And then we go down here, we multiply that by 10, so it's just gonna move the decimal once. We'll take this guy and multiply by 3. Oops. It's 748.5. And the last one, 299.5 times 2, 599. So that's the approximate sum of the service times for these 11 people, for these 24 people, these 10 people, these 3 people, and those 2 people. That's the approximate wait time that they had to wait to be served. Now, if we want to find the total, the sum of all of those lunch service times, well, we can't find it without the original data set, but if we add these together, that would be an approximation of the sum of all of the original X values. So we're going to add those together now. And we get about 8,025. And now that's an approximation of the sum of all of the data values. So 8,025 seconds. And if we want to divide by the total number of data values we had, that's the same as dividing by the sum of the frequencies. Because there were n service times here, 24 here, 10 here, 3 there, and 2 there. So we'll just do that. Add those guys together, we get 50. All right, so our sample mean is approximately the sum of those class midpoints times frequencies, which is an approximation of the sum of all of the actual values on our list, divided by the sample size, which happens to be the same as the sum of the frequencies. So this is 8,025 seconds divided by 50. And that's an approximation of the sample mean. So let's go back to our slides. Okay. And let's see. Do you have the same thing on the paper that we have on the slide? Yes. Yes. I always like to check just in case I made an arithmetic mistake. 8,025, 50, or sometimes it's just a typing error. Like you accidentally type it into your calculator incorrectly. Don't beat yourself up if that happens. It happens to us all. Okay, so you fill in this table with the class midpoints times the frequencies. And then the last step is to, well, you add up all the frequencies and you add up the class midpoints times the frequencies. And then the last step is to take those and divide. So there's a lot of text on this slide, but it's just summarizing what we've just talked about. We're approximating the mean without the original data set by approximating all the sample values in each class by the corresponding class midpoint. Like I don't actually know the value, but I bet it's close to this midpoint. So then we take it and we divide, or we multiply by the number of frequencies to get an approximation of the sum of the values in that class. And then we add up the sums for all the classes, and that's an approximation of the sum of all of the values. So when we do that, and we divide by the sample size, which is 50, we get this approximation of 60.5 seconds. So that's an approximation of the sample mean. That's the mean lunch service time for those folks that were going to McDonald's at lunchtime in our sample of 50. Now this is not the actual mean. Sometimes in, I think, our text, and as well as in the homework, the authors of the textbook will talk about finding the mean using a frequency distribution, but it's really not finding the mean. It's finding an approximation of the mean because we're using those class midpoints as a stand-in for the original values, and that's close. And there's a good reason we should use the class midpoints for the original values because it is likely to be close. But we're only doing that because we don't have the original values. If we want the exact mean, we have to use the original values and divide by the sample size. In the absence of that, this is pretty good. So that is the end of our lesson over computing the mean from a frequency distribution It's actually approximating the mean from a frequency distribution. Now, in the homework, you will also be asked often to take this approximation to the mean and compare it to the actual mean. So I'm going to show you this on a piece of paper over here. I don't actually have the sample, the true sample mean for the McDonald's lunch service times, but I want you to know how to do this in the homework. There are some videos in the statistics homework help playlist that will show you how to do this with a particular sample. But I want you to be prepared to do the homework as well. So I'm going to show you one more thing on my piece of paper before we go. Okay, there we go. So this is an approximation, and it was about 160.5. Now, if I want to compare this value, this approximate sample mean, to the actual sample mean, this is what we do. We always compare to the actual sample mean. So you might want to know, how different is this value from the actual sample mean? The way you would do that is you would take the actual mean, which can be computed by taking the original data values and dividing by the sample size, or sometimes they just give that to you. In the homework, they just tend to give that to you. And then you subtract this approximate mean that we found using the frequency distribution. So that's giving you the difference between the actual mean and the approximate mean. So it's giving you an error. And then we want to divide by the actual mean. So it's giving you this error now, and it's comparing it to the actual mean. So it's comparing this error to that base number. So we can think of this as a proportion. So if we want to think about how different this number is from this number, and you want it in the form of a percentage, this is called relative error. If I want percent error, I take this proportion and I multiply it by 100%. So this is percent error. So this is for us, for this particular application. It's the difference between the actual mean and the approximation of the mean. So it's our error. And then we're comparing it to the actual mean, and then we're multiplying by 100% to get percent error. And that is it for this video. I will see you in the next video, and we'll talk about the next learning outcome.